Yes, good morning. I'm Dr. T.S. Saranan, Associate Professor, Department of Computation Intelligence, SRM Institute of Science and Technology, Katangulattur. Today we are going to see about Dynamic Host Configuration Protocol, DHCP. What is DHCP? DHCP is Dynamic Host Configuration Protocol, and we are going to dynamically assign an IP address to any device. Question is, what is the need for DHCP? Because when a lab has 100 systems, automatically assigning IP address is very easier. When we go for manual assigning IP address, it cannot be done by a single person. We will be using 2 or 3 persons for allocating IP address. At that time, there may be a conflict in the IP address. So as there is a conflict in the IP address, the network may be hanged or network transmission may be stopped. That's one of the reason. Then in real-time applications means we can say that when a lab has 100 systems, all the 100 systems are connected to a server. And the students' login are enabled with the help of a server. And in that case, every time students are coming and accessing the content in the server, and they are saving the file in the server and executing the file at the server through the client interface. For example, a student comes on the first day and sits in the system number 1 and executes his program through his login credentials, which is provided by the server. At that time, the IP address will be allocated by the server using dynamic host configuration protocol. The second day, he is coming, sitting in the system number 2. He, with the login credentials, he will be able to access all the content which he has worked in the system number 1 on the previous day. When I say in the term login credentials, don't ensure that it is the login credentials of the computer system. No, it is the login credentials for his user login available in the server. That is one of the important application. Next, here, when you are going to see about the term dynamic host configuration protocol, it is purely a user data protocol, and it uses 2 ports. One is server port 67 and client port 68. Here we are going to use a discover, offer, request, acknowledgement process. Here, when you are going to say about the term, it is clearly indicated DORA process, DORA. DORA process. Then discover is going to be done. What is discover? Message is generated with the client. In order to discover there is any DHCP server, any dynamic IP address allocating server is available. Usually MAC address is sent as an identifier. As it is broadcaster, the servers available finds the request for the discovery. The free IP address will be provided to the client. And in that DHCP offer, you'll be having the client MAC address, IP address of the server, which is offering the IP address allocated to the client, subnet mask, and how much duration the IP address can be used. This information will be provided. And there may be multiple offers received to the client, because as a client is sending a broadcast message, any DHCP server will be sending the information. And why we are using two port numbers? First question, because we know that server is the person who is going to respond, client is the person who is going to request. As broadcasting is going to be done based upon the port number, accepting and rejecting will be done. Client will be sending a discover message, client will be broadcasting a discover message. At that time, the listening port will be 67. Only listening port with 67 alone accepts. The other port numbers discards. Similarly, when server is sending the message as a broadcast, the port number 68 alone receives. Other port numbers discards. The offer is going to be sent to the server, client from the server. Now client may receive multiple offers. For example, a DHCP server may send a IP address by 10 o'clock. Another DHCP server may send another IP address by 10:05. Client can choose any one of the IP address and it sends a ARP message in the group to identify that this IP address is not used. When no reply is received, the client understands the IP address is not going to be allocated and it sends a message to the server requesting to allocate this IP address for the client for the least duration provided in the offer. Now server accepts and server acknowledges with the request. Now here what we have here is, here we have two terms called as, one is DHCP decline and another one is DHCP negative acknowledgement. DHCP decline, it will be sent by the client to server when the client identifies that the IP address accepted by the client is already in use. That will be called as DHCP decline. Next one is DHCP negative acknowledgement. Here, server rejects the offer whenever client sends a request message. At that time, the server is unable to allocate the IP address. That type of situation is called as DHCP negative acknowledgement. And we can see over the DHCP in two ways. One is in same network, another one is in different network. When you are going to work DHCP in the same network, this will be the diagrammatic representation. Here what we have is, here we have your client port and server port is available. DHCP request has client port, server port, and CIP and SIP is nothing but we are going to say that client IP address and server IP address. There's a client CIP and SIP. Initially, when I am going to place the request, I don't have any client IP address. So what I will do means this SIP is nothing but the session initiation protocol. That is, I need IP address. That is the information is called as session initiation protocol. I need an IP address. That will be the content available in this SIP. DHCP request is placed, and this request is placed automatically. The same process as we seen previously will be taken place. First, what happens? A command will be provided by the server on UDP port number 67. and the server waits client to respond. After sending a message, the server waits client to respond. The server gets response from the booted client on port number 68. After that, a connection is now established between the source port 67. 67 is nothing but the source port, server port number, and destination port 68, client port number. After that, acknowledgement will be sent, a connection will be established when we are going for a same network. But when you're going for DHCP using network operation in different network, here we have a new concept called relay agent. In that, we have broadcast request and unicast request available. Here, relay agent is a mechanism used when you are going to use DHCP in a different network. Now, DHCP client is there. It cannot communicate with the server directly. Only the DHCP relay agent operates as an interface between DHCP client and server. The DHCP relay agent relays the DHCP messages between DHCP client and DHCP server on different networks. Because we know that we said that server port is 67. If the data is not communicated over the relay agent, the server port 67 will not be listened. And all the information passed without the relay agent will be discarded. Here what happens is, the relay agent is only aware about the server's address. Hence, it listens to the UDP port 67 for messages. Here the communication is done based upon relay agent based communication. Next, we are going to see about DHCP configuration.
Static address allocation. When you are going to say about the term static address allocation, a database is available. MAC address of the client are available in the database. Whenever the IP requested client matches with the MAC address available in the database, IP address will be allocated. In static DHCP, the IP address is fixed for a MAC address. Wherever times IP address is requested, the same IP address is allocated for the same MAC address. Dynamic DHCP. Yeah, you will have a dynamic mechanism of allocating the IP address based upon some time span. When the time expires, automatically the DHCP request needs to be renewed. The allocation will happen based upon request given, and the IP address is given based upon the availability. The IP address may vary time to time. But in case of static DHCP, the IP address will not vary. Next one is transition state. In a state, here a client initiates by sending a DHCP discover message. Selecting state, the server offers DHCP offer message. And client has to select one of the client, send the DHCP offer message. Requesting state. Until you are going to see the acknowledgement, the client is under requesting state. Till the server allocates the IP address, that client is going to be in requesting state. Bounding state. Bounding state is nothing but the client is IP address until the lease expires. The time is allocated until the time expires. The time is provided in the DHCP offer until the time expires. It will be called as bounding state. And there will be request to provider to renew when 50% of the lease period is expired. 50% means, for example, 1 hour access time is provided, then offer itself a request for renewing should be given. Renewing state. You are to renew after the time bound has been expired. With that, we have seen about the dynamic post configuration protocol. Thank you.